When we buy a lamp, we notice certain inscription written on this lamp. What does the inscription 220 volt represent? The rated voltage of the lamp. As we know, the rated voltage is the voltage needed by an electric device to function normally. In this case, the lamp needs 220 volt to function normally. Another inscription is written, 15W. What does this inscription represent? Together, we will figure out what this physical value is. At home, lamp, TV, iron, refrigerator, and many other electric appliances function normally under a voltage of 220 volt. But do these appliances need the same electric current to function normally? No, each one of them needs a different value of current to function normally. For example, the lamp needs 1 ampere to function normally, while the iron needs 5 ampere. The difference in the electric consumption of electric devices is related to a physical value called electric power. What do we mean by electric power? What factors affect electric power? How do we calculate electric power? All of these questions will be answered throughout this session. Let's get started. Let's take this example, where lamps 1 and 2 are incandescent lamps. Each lamp carries a certain inscription as shown in the figure. When the two lamps function normally under 6 volt, which lamp will consume more electricity? Lamp 2. Why? Since it carries more current. Let's take another example where lamps 2 and 3 are incandescent lamps. Both lamps carry the inscription 2 ampere, but when they function normally, which one consumes more electricity? Lamp 3. Why? Since it needs more voltage than that needed by lamp 2. So, the first example shows that for the same rated voltage, the lamp carrying greater current consumes more electricity. The second example shows that for the same current, the lamp with more rated voltage consumes more electricity. Out from this, what are the two factors that affect the consumption of electricity? Current and voltage. Let's go back to the first example where we concluded that the lamp carrying more current consumes more electricity. The two lamps 1 and 2 are turned on. They are functioning normally. Compare the power of lamp 1 to that of lamp 2. As you see, lamp 1 is glowing less than lamp 2. This means that the power of lamp 1 is less than that of lamp 2. Both lamps 1 and 2 function normally under a voltage of 6 volts, but lamp 2 carrying 2 ampere, a current more than that carried by lamp 1, produces more light, indicating more electric power. So, the more the current carried by an electric device, the more the consumed electricity, which means the more the electric power. Let's establish a relationship between current and electric power. For same voltage, as current increases, electric power increases. Now, let's go back again to the second example mentioned before, where we concluded that the lamp carrying more rated voltage consumes more electricity. The two lamps 2 and 3 are turned on. They are functioning normally. Compare the power of lamp 2 to that of lamp 3. As you see, lamp 2 is glowing less than lamp 3. This means that the power of lamp 2 is less than that of lamp 3. Both lamps 2 and 3 carry 2 amperes, but lamp 2 consumes 10 volts, a voltage more than that consumed by lamp 1. This lamp produces more light, indicating more electric power. So, the more the voltage consumed by an electric device, the more the electricity consumed, which means the more the electric power. Let's establish a relationship between voltage and electric power. For the same current, as voltage increases, electric power increases. By referring to these two relationships, deduce the formula that relates power, current, and voltage. Voltage and power are directly proportional. Also, current and power are directly proportional. So, to calculate power, we have to multiply voltage by current. So, the power consumed by an electric appliance is the product of the voltage across the terminals of this appliance by the current it carries. So, here's the formula. Power is equal to UI. P is the symbol of electric power. U is the symbol of voltage. I is the symbol of electric current. What is the SI unit of voltage? Volts. What is the SI unit of current? Ampere. Can you deduce the SI unit of electric power? SI unit of power is volts times ampere. Volts times amperes is designated by watt, symbolized by letter W. So, what is the SI unit of electric power? Let's solve this application, but before, keep in mind, rated power is the power consumed by an electric appliance when it is functioning normally. Given a lamp rated 6 volts and 2 amperes, calculate its rated power. To calculate the rated power, we have to multiply the rated voltage of the lamp by the current carried by this lamp during its normal functioning. In this case, the rated voltage is 6 volts and the current carried during normal functioning is 2 amperes. 6 volts times 2 amperes is equal to 12 watt. So, the rated power is 12 watt. Pause the video, solve this application, then check your answers. Calculate the power consumed by the lamp. Using the formula, power is equal to UI. The voltage across the lamp when functioning is 6 volts. The current carried by the lamp when functioning is 2 amperes. So, 6 times 2 is equal to 12 watt. 12 watt is the power consumed by the lamp. Is the lamp functioning normally? Think about it, then check your answer. No, it's not functioning normally, since the consumed power by the lamp, 12 watt, is less than its rated power, 21 watt. As you know, rated power is the power needed to be consumed by the lamp to function normally. The lamp should consume a power of 21 watt to function normally, but in this case, it's consuming less power than needed. That's why it's not functioning normally. Power is equal to UI. To calculate the voltage, we have to divide power by electric current. To calculate current, we divide power by voltage. Pause the video to solve this application, Then continue watching to check your answer. An iron carries the inscription 220 volts, 1000 watt. Calculate the current the iron carries when functioning normally. The power is equal to voltage multiplied by current. Here we have to calculate current, so we divide the power by voltage. 1000 watt divided by 220 volt, the answer will be 4.54 ampere. So 4.54 ampere is carried by the iron while functioning normally. The SI unit of electric power is watt, but electric power can be expressed by other units, such as megawatt, kilowatt, milliwatt, and microwatt. To convert from one unit to another, we either multiply or divide by 1000, depending on the units we are dealing with. To convert megawatt to kilowatt, we multiply by 1000. Whereas if you want to convert kilowatt to megawatt, we divide by 1000. Now, pause the video, solve the following application, then check your answer.